Hey everyone, and welcome back for another deep dive. Today, we're going to be tackling Bitcoin and quantum computing.
Ooh, exciting.
Yeah, it's a hot topic, and I think there's a lot of fear, uncertainty, doubt, FUD surrounding it.
For sure, and especially with all the recent advancements like Google's new Willow chip.
Exactly.
Yeah.
Yeah, you see those headlines, and it's like, oh no, is this the end of Bitcoin as we know it?
Yeah.
But, I think it's important to kind of like take a step back
Yeah.
and really look at, what are the facts? What's the reality of the situation? And that's what we're going to do today.
Yeah, we're going to cut through the hype and give you a balanced perspective on whether quantum computers really pose a threat to Bitcoin.
Exactly. And if so, how and when?
Yeah, and I think we'll uncover some fascinating details along the way.
For sure.
Like how many qubits you would need to crack Bitcoin's code. Spoiler, it's a lot.
Yeah, it's a mind-boggling number.
And we'll also explore some of the safeguards Bitcoin already has in place.
Yeah, and just to make sure we're all on the same page, can you give us a quick refresher on what makes Bitcoin secure in the first place?
Sure. So Bitcoin security relies on two main pillars.
Yeah.
We have ECDSA, which is used for digital signatures, and SHA-256, a hashing algorithm that ensures data integrity.
Okay, so ECDSA and SHA-256.
Exactly. Think of ECDSA like the lock on your Bitcoin wallet,
Okay,
and SHA-256 as the tamper-proof seal on every block in the blockchain.
got it. So those are the safeguards in place. But how could quantum computers potentially threaten those?
Well, quantum computers have a couple of theoretical tricks up their sleeve.
Okay.
We have Shor's algorithm and Grover's algorithm.
Okay.
Shor's algorithm could potentially crack the ECDSA, allowing someone to steal your Bitcoin.
Oh, no.
And Grover's algorithm could speed up brute force attacks on SHA-256, making it easier to find those rare solutions needed for mining.
But quantum computers are not nearly powerful enough to actually do any of this yet, right?
Right, that's the crucial part. They're not there yet.
Okay, so we're not all doomed tomorrow.
No, not at all.
But how far off are we from quantum computers actually being able to pose a threat?
Well, to break ECDSA in an hour, you would need a quantum computer with roughly 317 million qubits.
Wow, 317 million qubits.
Yeah, and today's most advanced quantum computers have around 100.
Oh, wow, that is quite a difference.
Yeah, even with the rapid pace of advancement, we're still years away from those kinds of numbers.
Okay, so it sounds like we have some breathing room.
We do. It's like knowing a hurricane is brewing way out at sea.
Okay.
It's something to keep an eye on, but there's no need to panic just yet. There's time to prepare.
Speaking of preparing, you mentioned that Bitcoin has some defenses already built in.
Right?
Can you tell us a little bit more about those?
Sure. One of the most important is Bitcoin's difficulty adjustment.
Got it.
So the network automatically adjusts the difficulty of mining to keep the process consistent,
Okay.
even if someone suddenly brings a lot more computing power to the table.
So even if a quantum computer could mine faster, the network would compensate.
Exactly. It's like a self-regulating system.
That's pretty clever. Are there other safeguards?
Absolutely. You as a Bitcoin user can also take steps to protect yourself.
Okay.
Following best practices for public key security is crucial.
Great.
Never reuse addresses.
Okay.
And think of it like changing your passwords regularly.
Got it.
It makes it much harder for anyone, even with a quantum computer, to target your funds.
That's a good point. It seems like, we have some control over our own security destiny, even in the face of all this new tech.
Right.
What about that hash obfuscated addresses thing I keep hearing
Oh,
about?
wow. Yes, that's another layer of protection.
All right.
So it makes it even harder for an attacker to figure out which addresses to target, even if they have a quantum computer helping them.
So even if quantum computers suddenly became super powerful tomorrow, a lot of Bitcoin wallets would be safe because of these built-in defenses and best practices.
Exactly. And this brings us to a really important point. Bitcoin is not static.
Right.
It's designed to evolve and adapt to new challenges.
Okay, so Bitcoin has a few tricks up its sleeve. But what about the future? Can it actually stay ahead of these quantum advancements?
Well, what's fascinating here is that Bitcoin's design already allows for upgrades.
Yeah.
Satoshi Nakamoto, Bitcoin's creator, even mentioned this back in 2010, suggesting the network could transition to more quantum-resistant algorithms if needed.
It's like Satoshi had a crystal ball.
Right.
And we can't forget the power of the Bitcoin community.
Yes.
It's constantly evolving, always seeking to improve and stay ahead of the curve.
Absolutely. Bitcoin's decentralized governance allows for rapid collaborative solutions.
Okay.
Developers are already working on ways to make Bitcoin even more quantum resistant.
So they're not just sitting around waiting for this to become a problem.
No, they're not.
That's good to hear.
And there's this fascinating proposal called Qubit, which introduces post-quantum public keys.
Okay.
But remember, this quantum threat isn't unique to Bitcoin.
Oh, right. This could affect anything that relies on encryption.
Exactly. We're talking online banking communications, even national security.
So it's like a global cybersecurity challenge.
It is, but that also means the whole world is working on solutions.
Okay, so at least we're not alone in this fight.
No, you're not.
And in some ways, Bitcoin's decentralized nature might actually give it an edge in adapting compared to those slower, more centralized systems.
That's a really interesting point. It's like a nimble speedboat versus a giant cargo ship.
Yeah, I like that.
You know, the speedboat can turn and adjust course much faster.
So we've established that quantum computing is a real but not imminent threat,
Right.
and that there are folks working to make Bitcoin even more resilient. But let's get down to the question that everyone's thinking. When should we really start worrying?
Well, that's the million-dollar question. And honestly, there's no one definitive answer.
Okay.
Expert predictions vary quite a bit. The National Institute for Standards and Technology, NIST, recommends migrating to new cryptographic systems by 2035 to be on the safe side.
Okay, so 2035, we have at least a decade, it sounds like.
At least a decade. Yeah, and I've heard some people in the Bitcoin space are even more optimistic about that timeline.
Okay, what are they saying?
Well, for instance, the CTO of Ledger, Charles Guillemet, has said that Bitcoin isn't affected by some of the specific forward secrecy risks that NIST is concerned about.
Okay.
That means that even if way down the line someone could crack past Bitcoin transactions, future ones would still be secure.
Okay, that's good to hear.
And if we look at IBM, for example, they have a quantum computing roadmap that projects a few thousand qubits by 2033.
Okay.
Remember, we're talking about needing millions of qubits to really threaten Bitcoin.
Right.
And within the Bitcoin community, you'll find a range of opinions.
Okay.
Some estimating a decade or two, others saying, not in my lifetime.
So while the timeline is uncertain, it seems like the key takeaway is that the Bitcoin community is taking this issue seriously
Yes,
and actively preparing for the future.
exactly. Preparedness, not panic.
Okay,
There's no need to lose sleep over this just yet.
good to hear.
But I do have some good news that might surprise you.
Okay, I'm all ears.
According to a study by Deloitte, about 75% of Bitcoin wallets are already safe from potential quantum attacks just by virtue of the type of address they use.
Wait, really? 75%? That's a surprisingly high number. So even without any major changes to Bitcoin itself, a huge chunk of the network is already quantum resistant.
That's correct.
Wow. Okay, why is that?
Well, it all comes down to how those addresses are structured. It's like having a lock that's too complex for even the most advanced quantum key to pick.
Interesting.
Even without consensus rule changes, wallets can already implement quantum-resistant signature schemes, laying the groundwork for a smooth transition.
That's fantastic news. It seems like a lot of thought and foresight has gone into building Bitcoin security.
Absolutely.
And that brings us to some of the specific solutions being proposed to make Bitcoin even more resilient, starting with that Qubit proposal we mentioned earlier.
Yes.
Can you tell us a bit more about that?
Of course. Of course. So Qubit is a fascinating proposal that introduces a new type of address called pay to quantum resistant hash, or P2QRH for short.
Okay, P2QRH.
Yeah, and these addresses use multiple quantum-resistant signature schemes, making them very difficult to crack, even with Shor's algorithm.
So it's like adding multiple locks to your door just to be extra safe.
Exactly.
But why would people switch to these new addresses? What's the incentive?
Well, that's where the clever economics of Bitcoin come into play.
Okay.
The Qubit proposal includes a substantial discount in transaction fees for using P2QRH addresses.
Oh, wow. Okay, so you get enhanced security and lower costs.
Exactly. It's a win-win.
I love how the Bitcoin system is designed to kind of reward good behavior.
Right.
So how would this all roll out? Is it a sudden change or more of a gradual process?
Well, the Qubit plan has 4 stages.
Yeah.
First, they establish a standard for these new quantum-resistant addresses.
Okay.
Then they make sure they're compatible with Taproot, which is a recent Bitcoin upgrade.
Okay.
After that, they activate the changes across the whole network through a soft fork.
Okay.
And finally, they aim to create a truly quantum-secure address standard in the future.
So it's a carefully planned roadmap. But Qubit isn't the only option on the table, right?
Yeah.
I've heard whispers of other approaches being explored.
That's right. There's another idea that involves reactivating a previously deactivated opcode called OPTAT.
OPCAT.
Okay? And it could enable quantum-resistant addresses in a different way. However, there are some concerns about potential centralization
Okay,
issues.
so it's a topic that requires careful consideration.
Exactly. It's like having a powerful tool that could be used for good or bad, depending on who controls it.
Right, it sounds like there are multiple paths forward, each with its own advantages and challenges.
Right.
And that brings us to another fascinating concept, Starks. What are those?
Starks, or scalable transparent arguments of knowledge, are a mouthful, I know.
Yeah.
But essentially, they're a way to prove something is true without revealing the underlying information. They offer a powerful way to improve security and privacy, and could even bring scalability improvements to Bitcoin.
Wow, Starks sound like something straight out of a sci-fi movie.
They kind of are.
But the point is, the Bitcoin community has a whole toolbox of options to address this quantum challenge.
Right.
It's not a question of if solutions can be found, but which solutions will be implemented and when.
Exactly. And that's what I find so exciting about this whole topic. It's not just about the technology itself, but also the human ingenuity and collaboration behind it.
Exactly. And that's something that Blockstream CEO Adam Back captured perfectly when he said, I think quantum readiness is the right balance. Not like there is any current risk, nor likely for this decade or probably the next, but being ready is okay. I love that being ready is okay. That should be everyone's motto, not just in the Bitcoin world, but in life in general.
I agree. It speaks to a mindset of proactive planning and acknowledging potential challenges without succumbing to fear or hype.
So to sum up what we've learned so far, quantum computing is a fascinating field with the potential to change our world in profound ways.
Absolutely.
And while it does present a real challenge to Bitcoin, it's not an existential threat. The community is actively researching and implementing solutions to ensure Bitcoin's long-term security.
Exactly. It's an ongoing process, and there will undoubtedly be more challenges and innovations along the way. But the key takeaway is that Bitcoin is designed to evolve and adapt.
Right. It's not a static system. It's a living, breathing ecosystem that's constantly innovating.
Exactly.
And that's what makes this technology so exciting. Now, before we move on to the next part of our deep dive, I want to address something we haven't talked about yet. What would a quantum attack on Bitcoin actually look like?
That's a great question, and one we'll explore in more detail in the next part of our deep dive.
Stay tuned. Welcome back to the final part of our deep dive. We've explored the potential threat of quantum computing, the defenses Bitcoin already has, and the ongoing work to make it even more quantum resistant.
Right.
Now let's get into some specifics about those quantum resistant technologies.
Okay, this is where things get really exciting for me.
Okay.
It's like peeking into the workshops where the future of cryptography is being forged.
I love that image.
Yeah.
So what are some of the most promising tools in this cryptographic toolbox?
Well, one of the front runners is a family of algorithms known as lattice-based cryptography.
Okay.
Remember that analogy we talked about earlier about finding the shortest path on a constantly shifting 3D chessboard?
Oh, yeah.
That's what makes these algorithms so difficult for even quantum computers to crack.
Right. It's like trying to hit a moving target in the dark.
Exactly. And because of that difficulty, lattice-based cryptography is a strong foundation for building encryption algorithms that can withstand those quantum attacks we talked about.
So are there specific lattice-based algorithms being considered for Bitcoin?
Absolutely. One example is crystals dilithium.
Crystals dilithium.
Yeah, it's a digital signature scheme that's already a finalist in a competition run by the National Institute of Standards and Technology, or NIST.
Wow.
They're trying to find the best post-quantum cryptography algorithms, so making it to the finals is a big deal.
It's like being nominated for a cryptographic Oscar. So we've got crystals dilithium. Any other contenders using this lattice approach?
Yes, there's another one called Falcon, also a digital signature scheme.
Okay.
It's known for being very efficient and compact, which is important when you're dealing with a system as vast as Bitcoin.
So we have a couple of strong contenders using lattices. What other approaches are out there?
Another interesting area is code-based cryptography.
Code-based cryptography.
Yeah, it's a bit more technical to explain.
Okay.
But essentially, it's based on the idea of using error-correcting codes to hide information.
Okay.
Imagine trying to decipher a message that's been scrambled with a secret code.
Oh, like a secret decoder ring, but on a much more complex level?
Exactly. And it's another tool in the arsenal for creating a quantum-resistant Bitcoin.
So we have lattices and codes. Anything else?
Well, there's one more approach that might surprise you: hash-based cryptography.
Hash-based cryptography.
Yeah, remember those hash functions like SHA-256 that we talked about earlier?
Right, the ones that are already a key part of Bitcoin security?
Exactly, the ones that make sure no one's tampering with the blockchain.
Right.
And it turns out that some hash-based signatures are thought to be quantum-resistant, too.
So even our trusty hash functions could play a role in the quantum-resistant future of Bitcoin. I love how we're building on existing strengths.
Exactly.
What's an example of a hash-based signature that could work?
One prominent example is SphinCS+.
SphinCS+.
Yeah. It's known for being very secure and for having relatively small signature sizes, which is important for efficiency.
So to recap, we have lattices, codes, and hashes all working together to create a multi-layered defense against quantum attacks. It's like having a security system with multiple locks alarms and maybe even a guard dog.
I like the way you think. And the beauty of this approach is that these different methods can complement each other,
Right.
providing a more robust and adaptable security system overall.
So it's not about choosing one winner, but about using the best tools for the job
Exactly.
and making sure they all work together seamlessly.
Right. It's a dynamic and evolving field, with researchers constantly exploring new ideas and pushing the boundaries of what's possible.
This has been an incredible deep dive. We've covered a lot of ground, from the theoretical threats of quantum computing to the very specific technologies being developed to address them. But before we wrap up, I want to leave our listeners with a few key takeaways.
Yeah, me too. It's important to distill all this information into actionable insights.
So first and foremost, I think it's crucial to understand that while quantum computing presents real challenges, it's not an insurmountable threat. The Bitcoin community is proactive, innovative, and dedicated to ensuring Bitcoin's long-term security.
Right. And it's also important to remember that the transition to quantum resistance will likely be a gradual, multifaceted process.
Yeah.
There will be ongoing research upgrades and improvements along the way.
And finally, and perhaps most importantly, the future of Bitcoin is bright, even in the face of quantum computing. The core principles that make Bitcoin valuable will remain, and the community is well equipped to adapt and thrive in this evolving technological landscape.
Remember, Bitcoin is more than just code. It's a global community, a shared vision, and a testament to the power of human ingenuity.
I think that's a perfect note to end on. So to our listeners, we encourage you to keep learning, stay curious, and embrace the challenges ahead. As Adam Back said, being ready is okay. And with that, happy diving.